Okay, so the question we've been given today is we need to determine the gradient of the following without the assistance of our calculators. So basically what that question is asking us to do is it's asking us to use calculus or differentiation to find out what the gradient of a tangent to this function is at the point x equals 0. So there are many ways we can go about this, but I think the simplest way to do it is to rearrange the function we're given a little bit and then use what's known as the chain rule to differentiate it. Now, what we're going to do first is to rearrange this function. We're going to move the 2x squared plus 1 all cubed from the numerator into the denominator by just taking it to a negative power. So that will end up as this. Y equals 2x squared plus 1 all to the power of negative 3. Cool, so these two are equivalent functions. Now, to start differentiating it, we're going to employ what's called the chain rule, and the reason we're using a chain rule here is because we have, or what my teacher used to always say, an inside function and an outside function. We've got an inside function, which is 2x squared plus 1, and an outside function, which is something, or we used to call it u, all to the negative 3. And the chain rule that we're going to employ in this question is dy over dx is equal to dy over what we call du times du over dx. And what you'll see here is the u's will cancel and you'll get back to dy dx. Why is this significant? Well, you're about to find out. We'll change colour. So we've got to start with y in terms of u. Now what we'll have here is we're going to label the inside function u. So we'll have u is equal to 2x squared plus 1, and y is going to be equal to, well, we've got the 2x squared plus 1, which we now are calling u, to the power of negative 3. Cool. So now what we have to do is we have to differentiate y in terms of u and u in terms of x. So we'll start with the top one. Cool. So this is u in terms of x. So the differential of this is going to be du dx is equal to 2 times by 2 is 4 x, and we can lower the power by 1, it goes to 1, so it's unnecessary, and the 1 just drops off. Now we're going to do y in terms of u. So dy du is going to equal, now the 3 comes down, we times by the 1 coefficient that's out the front, and we'll have negative 3 u, and we reduce the power by 1 to the power of negative 4. Great. Alright, that's all that legwork done. Now what we have to do is we have to combine these two functions that we've just found. And what we'll see is, so dy dx according to the chain rule is equal to dy du, which is negative 3 u to the power of negative 4 times du dx, which is just 4x. Great. So what we can do now is we can substitute our u back into the final equation because we know that u is 2x plus 1. So this is going to equal negative 3, 2x squared plus 1, all to the power of negative 4, times 4x. Now, that's basically almost fully done, but it's going to be very difficult for us to work with a formula in this form. So, because of this negative power to start with, so negative power means it's got to go down underneath, so it's going to be 1 over whatever's there. So it'll be negative 3 divided by 2x squared plus 1 all to the power of 4 times 4x. And finally, it's going to equal negative 3. We can put the 4 up the top, so negative 3 times 4 is negative 12 x divided by, it's pretty shonky, divided by 2x squared plus 1 all to the 4. Okay, well that's all well and good. We've got this, but now we need to figure out what the derivative is at the point x equals 0. So I'll just continue it up here. So basically what we have to do is we have to sub in x equals 0 into our gradient function. Two bracket 0 and what this actually comes out to be is, well, 0 times negative 12 is 0. This will all be 0 plus 1 all to the 4 is just 1. So what we can then write is, therefore, at the point zero comma 1, which is what they've given us up the top, the function has a gradient of 0.